Hello guys, this is another video by Fundo on fractions in algebra. So when we're dealing with algebra, we are dealing with numbers with letters, okay? So in algebra, different letters cannot actually add or subtract each other, but they can actually multiply each other, okay? So when multiplying algebraic fractions always fully factorize the numerators and the denominators. So when you factorize the numerators and the denominators, it may then be possible for you to divide the numerator and the denominator by any factors which they have in common, okay? So these 2 points, we're actually going to illustrate them on this example that we have. So it's a question and we're asked to reduce it to its lowest terms. So we first factorize our numerator and our denominator, okay? So when factorizing, we factorize by our highest common factor. So the highest common factor of our numerator is 2mu squared, okay? So if we factorize the numerator, it will be 2mu squared multiplying by 3m minus 2n, okay? And the highest common factor of our denominator is mu. And if we factorize our denominator, we'll be left with mu multiplying 9m squared minus 4u squared. And in this case, the 9m squared minus 4u squared, it's a perfect square. So we actually find the difference of two squares. And on the denominator, we have mu 3m plus 2u m minus 2u, okay? So now we've got common elements on our numerator and our denominator. So we then divide both the numerator and our denominator by mu 3m minus 2u, and those will actually cancel out each other, and on our numerator we are left with 2u, and on our denominator we are left with 3m plus 2u. Moving on to example 2, we've got a fraction a squared plus x squared minus 6x squared over 2x squared plus ax minus a squared. So in this case, both our numerator and our denominator, they are quadratic functions. So I believe you all know how to factorize quadratic functions. So those steps that you take when factorizing quadratic functions are the same steps that you take when factorizing those quadratic functions, okay? So when we factorize our numerator, we get a minus 2x multiplied by a plus 3x, and if you factorize our denominator, we get 2x minus a multiplied by x plus a, okay? So on the denominator, we can simply factorize a negative, and then it will be a minus 2x, and then the a minus 2x on the numerator then cancel out with the a minus 2x on the denominator there. Yes, they then cancel out each other. And then on the numerator, we're left with a plus 3x. And on the denominator, we're left with x plus a. And don't forget to put the negative sign because we have factorized a negative on the denominator, okay? So on exercise 1, we are given 3 fractions which we are asked to factorize. So we are going to try a few, and the others you will solve them on your own. So moving on to the solutions, okay, you do number 1 is easy, so you do that on your own. So moving on to number 2, okay, so we've got the fraction. On the numerator, we've got 28c squared d squared e squared, and on the denominator, we've got 35c e to the power 4. Okay, so before we go any further, like before we go on to the letters, to the letters, the unknowns, we can first simplify the numbers. As you can see, 7 is the highest common factor which can divide into both 28 and 35. So if we divide 28 by 7, we get a 4, and if we divide 35 by 7, we get a 5. To get our numerator as 4c squared d squared e squared, and our denominator is 5c e to the power 4. Okay, so as we can see, the highest power on both our denominator and numerator is CE to the power 2. So if we then divide both the numerator and the denominator by CE to the power 2, we get our numerator being 4CD squared and our denominator as 5e to the power 2. So we have actually simplified that fraction, okay? And be very careful when dividing your letters or your unknowns, okay? So moving on to the next question, which is number 3, okay? We've got x squared minus 4x is our numerator and x squared minus 4 on our denominator. As you can see, the numerator is not a perfect square, so you can't find the difference of 2 squared. You then simplify, you then factorize the numerator. So the common highest factor is x. So if we factorize x on the numerator, we get x multiplying x minus 4. And on the denominator, that's a perfect square. So we just find the difference of the 2 squares, okay? Then the 4 minus x on the numerator then cancels out with the 4 minus x on the denominator. And then we will be left with x on the numerator and 4x and x plus 4 on the denominator, okay? So now moving on to multiplication and division of fractions, okay? So factorize fully first, then divide the numerator and the denominator by any common factors. This is a rule in algebra that you should always know. Before you are even told to simplify, multiply, divide, or do what, you should first factorize the numerator and your denominator, okay? So here we've got 3 questions which we're going to try to solve. We're going to do a few, and I believe 1 or 2 you're going to solve them on your own. Question 1, we've got the 2 fractions multiplying each other. So the first fraction is a squared plus 2a minus 3 over a squared minus 16 multiplying the fraction a plus 4 over a squared plus 8a plus 15, okay? So on the first question, the numerator is a quadratic function, so you just factorize that using the quadratic formula, like the quadratic way of factorizing functions, okay? And then the denominator is a perfect square. You just find the difference of the 2 squares to get a minus 4, a plus 4. And then moving on to the next fraction, the numerator is perfect and the denominator is a quadratic function. Then you just factorize that quadratic function to get a plus 5 and a plus 3. So when we multiply those fractions, we are just combining the numerators only and the denominators only. So if we combine the numerators and the denominators, then the common factors on the numerators and the denominators can then cancel out each other. So in this case, a plus 4 on the denominator will then cancel out a plus 4 on the numerator, and a plus 3 on the denominator will also cancel out a plus 3 on the numerator, and then we are left with the fraction a minus 1 over a minus 4 multiplied by a plus 5. So we've actually simplified our algebraic fraction. So moving on to number 2, we've got the 2 fractions, but they're dividing each other, okay? So you know, if there is a division sign, you simply invert the numerator and the denominator of the post-dividing fraction, okay? So in this case, our numerator is m squared minus a squared, and our denominator is m squared plus bm plus am plus ab. Whew, that's a lot. And our next fraction is m squared minus 2am plus a squared over cm plus ab, and we're actually going to invert that fraction, okay? So our numerator is a perfect square, so we find the difference of perfect squares. So it's going to be m minus a multiplied by m plus a, and then our denominator, we just factorize that. We're just finding the highest common factor, and then we just factorize the, so it's going to be m plus b, m plus a, okay? And On the other fraction, we then factorize a c on the numerator to get c m plus b, and on the denominator is a quadratic expression, so you then simplify it. You then factorize it to get m minus a, m minus a. So the m minus a on the numerator will then cancel out the m minus a on the denominator, as shown there, and then the m plus a would then cancel out the m plus a on the denominator, and then the m plus b on the denominator would then cancel out the m plus b on the denominator. So in this case, we are dividing above and below. In this case, our above is the numerator and the below is the denominator by m minus a, m plus a, and m plus b to get c over m minus a. So we have actually simplified our algebraic fraction. So try to solve number 3 on your own, okay? So moving on to addition and subtraction of algebraic functions. So we are going to illustrate this by solving one or two questions here, okay? So moving on to question 1, we've got the fraction 2 plus 6a squared plus 2b squared over 3ab minus 4a minus b over 2b. Okay, so when solving fractions, we first find the common denominator. So in this case, we've got 1, 3ab, and 2b as our denominator. So the common denominator of these denominators is 6ab. Okay, so we then divide all the denominators into our common denominator. So 1 into 6ab, we get 6ab. Then we multiply it by the numerator, so it will be 2 multiplied by 6ab. Moving on to the next. It's 3ab into 6ab to get a 2. And this 2 is multiplying with the elements on the numerator, so that will be 6a squared plus 2b squared. Then moving on to the next. 2b into 6ab, we get 3a, it is then multiplying the numerator, which is 4a plus b. Then we open our brackets. The 2, if we multiply 2 by 6ab, we get 12ab, and in that case, if we multiply that, we get 12a squared plus 4b squared, and if we multiply negative 3a by 4ab, we get 12a squared plus 3b squared. Okay, so we are now simplifying the numerator. So if we add 12ab and 3ab, we get 15ab. Okay, and if we add 12a squared minus 12a squared, we get a 0, and we are left with 4ab on our numerator. So it will be 50ab plus 4b squared, and on our denominator we've got 6ab. Okay, so if we factorize our numerator with 6 as our highest common factor, we get, with b as our highest common factor, we get 15a plus 4b being multiplied by b, the highest common factor, of our denominator, which is 6ab. So if we then divide our numerator and our denominator by the common factor, which is b, we are then left with 15a plus 4b over 6a. So that's how you do it, guys. So moving on to number 2, we've got the fraction 3 over m squared plus mn minus 2m squared minus 2 over m squared minus 4mn plus 3n squared. So in this case, both our denominators, they are quadratic expressions, so we just factorize them the quadratic way. So on the first fraction, our denominator will now be m minus n multiplied by m plus 2n, and on the other side, that will be m minus n multiplied by m minus 3n. Okay, so the lowest common multiple of both the denominators will actually be m minus n, m plus 2n, m minus 3n. Okay, so if we put that as our denominator, we then divide the lowest common denominator by the denominator of our first fraction. So if we divide that by m minus n and m plus 2n, we are then left with m minus 3n. So if we then multiply m minus 3n by our numerator, it will be left as 3 multiplied by m minus 3n. Moving on to the second denominator, we divide it into our lowest common denominator. So those will actually cancel each other, the m minus n, the m minus 3n, and we are left with m plus 2n, and it will multiply with our numerator to get a negative 2 multiplying m plus 2n. Okay, so if we open up our brackets on the numerator, we are left with 3m minus 9n minus 2m minus 4n, and in our denominator we have m minus n, m plus 2n, m minus 3n. So if we simplify the numerator, we are left with m minus 13n, and on the denominator we've got m minus n, m plus 2n, m minus 3n. So we can no longer factorize the numerator, hence there is no common factor. So we've actually simplified our fraction, our algebraic fraction. We've actually multiplied them. So try to solve the last question on your own, okay, following the exact same steps that we have been doing. Don't forget to factorize both the numerator and the denominator. So moving on to equations with fractions. In this case, we are dealing with equations with algebraic fractions. So we are given 3 equations. So we're going to solve 1 or 2, and you actually have 1 you will solve on your own. So moving on to question 1, we've got the equation 1 over 3a minus 1 being equal to 2 over a plus 1 minus 3 over 8. Okay, so we're going to treat these equations as fractions, okay, but not ignoring our equal sign. Okay, so the lowest common multiple of our denominators will actually be 8 multiplied by 3a minus 1 multiplied by a plus 1. Okay, so we then multiply this LCM of the denominators by each element on the right hand side and each element on the left hand side. Okay, so in this case 1 over 3a minus 1 is actually going to multiply with the LCM of the denominators, which is 8 3a minus 1a plus 1, and 2 over a plus 1 is also going to multiply with the LCM of the denominators, and 3 over 8 is also going to multiply with the LCM of the denominators. Okay, so moving on to the left hand side. So if 1 over 3a minus 1 multiplies with the LCM of the denominators, the 3a minus 1 then on the denominator then cancels out with the 3a minus 1, and you will be left with 8 multiplied by a plus 1. Okay, so moving on to the right hand side, the a plus 1 on the denominator then cancels out with the a plus 1 on the LCM of the denominators, and then we multiply the 2 by 8 to get a 16, and it will be multiplying 3a minus 1. Okay, moving on to 3 over 8, the 8 will cancel out with the 8 on the LCM of the denominators, and then we will be left with 3 multiplied with 3a minus 1, a plus 1. Okay, so now simplifying what's on the left hand side and on what's on the right hand side when you open up the brackets. On our left hand side we've got 8a plus 8, 48a minus 16 minus 3a squared plus 2a minus 1. And then if you open the remaining two brackets, we then have 9a squared minus 6a plus 3. Okay, so we then take the elements on the right hand side, then we put them on our left hand side. You do what you feel like you want to do. If you want to take the left hand side elements and put them on your right, that's still okay, but in this case we took the right hand side elements and then we put them on our left. And remember, when you transfer the right hand elements on the left, the signs of each element will change. Okay, so in this case it will be 8a plus 8 minus 48a plus 16 plus 9a squared plus 6a minus 3a being equal to 0. Okay, so if we simplify the elements on the left hand side, we get 9a squared minus 34a plus 24 being equal to 0. So this is now a quadratic expression. We then factorize it to get a minus 3, 9a minus 7 being equal to 0. Then we equate each individual factor to 0. So if we equate a minus 3 to 0, our a will become 3. And if we equate 9a minus 7 to 0, our a then becomes 7 over a. So this is how you 7 over 9. So this is how you solve your algebraic fraction equations. So on question 2, we've got the equation 3 over x squared minus 5x plus 6 being equal to 2 over x squared minus x minus 6. So we then first factorize the denominators. So it will be 3 over x minus 2, x minus 3 being equal to 2 over 3 minus x, x plus 2. In this case, both our denominators were quadratic expressions, so we first factorized them. So the LCM of the denominators in this case is actually x minus 2, x minus 3, x plus 2. So actually multiply both sides of the equation by our LCM of the denominator. So if we multiply our LCM of the denominator by the elements on the left hand side, the x minus 2, x minus 3 will cancel out the x minus 2, x minus 3 on the denominator, and we are left with 3 multiplying x plus 2. Okay, so moving on to the right hand side, the x minus 3x plus 2 elements on the denominators, they'll actually cancel out with the x minus 3 and the x plus 2 there. Okay, and then in this case we'll be left with 2 multiplied by x minus 2. So when we open our brackets on the left hand side, we've got 3x plus 6 and on the right hand side 2x minus 4. So if we group our like terms, the x elements on the left and the numbers on the right, we got 3x minus 2 on the left hand side and negative 4 minus 6 on the right. So our x will actually be equal to negative 10. So try to solve the last question on your own for practice sake, and thank you for watching this video, and don't forget to request for more videos. Bye bye.